A ratio is used to compare quantities. It doesn't give actual values. So, for example, you might have a bag of coloured beads. There might be red beads and white beads. And you might be told that the ratio of red beads to white beads is 2 to 3. This is written, the ratio of red beads to white beads, the two dots are ratio, and we are told that the ratio of red beads to white beads is 2 to 3. This means that for every 2 red beads, there are 3 white beads. So we may have 2 red and 3 white, so the ratio 2 to 3. We may have 4 red and 6 white, so you have a ratio of 4 to 6, but if you look at these two numbers, they are both divisible by 2 and will actually simplify to give you the ratio 2 to 3. It may be that you have 8 red beads and 12 white beads. So you have 8 red beads and 12 white beads. Both of those numbers are divisible by 4, and again you get the ratio 2 to 3. So as you can see, the ratio tells you the connection between the quantities. It doesn't tell you how many beads there actually are in the bag. All of these ratios, 2 to 3, 4 to 6, 8 to 12, they are all called equivalent ratios because they all simplify down to the same ratio of 2 to 3. So they're all equivalent. Equivalent ratios can be found by multiplying or dividing each part of the ratio by the same number. So, for example, a ratio of 2 to 3, if I multiply that side by 5 and multiply that side by 5, then I get 10 to 15. Same ratio, it's like a fraction that hasn't been cancelled down, 10 to 15. Similarly, if I have 4 to 6, divide that by 2, divide that by 2. Again, 4 divided by 2 is 2, 6 divided by 2 is 3, gives me the ratio 2 to 3. All equivalent ratios. It's usual to give the ratio as simply as possible, which means cancel down as much as possible. So 2 to 3 is the simplest form of this ratio, and that's usually how it's given. Although a ratio doesn't use units, it's important that the things you are comparing both have the same units, as you will see when we come to a question later on. So let's just see how these simple ratios work with a couple of examples. So you may get a question, something like, write the following ratio in its simplest form. And its simplest form just means that there's nothing you can divide both sides by. So, for example, if we had the ratio 12 to 21, both of these will divide by 3. So I can divide 12 by 3 to give me 4. I can divide 21 by 3 to give me 7. So the simplest form would be 4 to 7. Another example, you don't just need to have 2 numbers. So again, write in its simplest form. You could have a ratio 5 to 20 to 30. Again, if you look at these numbers, every single number will divide by 5. So if I divide each number by 5, 5 divided by 5 is 1, 20 divided by 5 is 4, 30 divided by 5 is 6. So the simplest form is 1 to 4 to 6. Now, although 4 and 6 still have a common factor, you could still divide those by 2. We cannot go any further because we cannot divide the 1 by 2. So the simplest form is 1 to 4 to 6. Suppose a question asks you to write in its simplest form, But this time it says write in its simplest form 40 centimetres to 2 metres. Now here you are given the quantities in units, with units, and they both have different units. So the first thing you need to do is write both quantities with the same units. So we're looking at the first quantity being 40 centimetres, and the second quantity, if I convert it to centimetres, will be 200 centimetres. Now they both have the same units, I can write them as a ratio. So the ratio is 40 to 200, and if you look at both of those numbers, they will both divide by 40. 40 divided by 40 is 1, and 200 divided by 40 is 5. So the simplest form would be 1 to 5.